Welcome to our discussion on atmospheric dynamics. We're working our way through balanced flows, and right now we're talking about the geostrophic wind. What we're going to do is look at the variables that affect the geostrophic wind. And we'll start out with either the pressure gradient or the height gradient. You remember, we're looking at the pressure gradient on constant altitude charts, and we're looking at the height gradient on constant pressure charts. So if the pressure or height gradient is very strong, then you're going to have a strong wind. And when do you have a strong pressure or height gradient? How do you know you have a strong pressure or height gradient? That is when you see many contours or many isobars very close to each other. In other words, over a very short distance, you have a very big change in either pressure or height, depending upon which chart you're looking at. So generally speaking, the stronger the gradient, the stronger the wind. And also, the weaker the gradient, the weaker the wind. Another thing that determines the strength of the geostrophic wind is the Coriolis parameter. And the Coriolis parameter varies with latitude. So you would have a much stronger Coriolis force as you move north because it's a function of latitude. And as you move south towards the equator, your Coriolis parameter will become smaller. So if your Coriolis is very big, if you're at northern latitudes, then your wind is going to be relatively weaker. And if you are moving towards the equator, where you have a much weaker Coriolis force, then the wind is going to become stronger. So here's some examples. The picture on the left, you see a height gradient up at 64 degrees north latitude. And on the right, you see a height gradient at 40 degrees of latitude. It looks like the gradient is about the same. In other words, the distance between the contours is about the same. Notice that at 64 degrees north latitude, the wind is only 30 knots. At 40 degrees north latitude, the wind varies somewhere between 50 to 80 knots. So what I'm trying to say here is that to get a strong wind, you need a much tighter gradient at northern latitudes than you do at southern latitudes. At higher latitudes, you need a much stronger gradient because the Coriolis force is much stronger. And the last few things we'll look at that determine the geostrophic wind strength is on constant altitude charts, density. And of course, the higher the density, the bigger the density, the weaker the wind. And the lower the density, the stronger the wind. Now that's only on constant altitude charts, and typically we don't really measure density in our atmosphere. The other thing is gravity. And for all practical purposes, gravity is constant through much of the atmosphere. It does vary, but very slightly, so it's not a big factor. So just to summarize, the geostrophic wind assumptions are that, number one, there is no acceleration. And acceleration means it does not change magnitude, in other words, speed, nor does it change direction. It's straight flow. Also, it is frictionless, so that means it's well above the boundary layer in the free atmosphere. Sometimes acceleration cannot be ignored. If you look at weather charts, you'll see that there is significant acceleration going on in our atmosphere. So we have to figure out whether the wind is close to geostrophic or not. And to do that, we'll talk about the Rossby number.